Hello. Today we're gonna learn how to compute area between curves. Um, Normally, these types of problems will give you two curves. Then you have to find the area between those two curves. Um, First, I'm going to give you the motivation. Let's say you are given these two curves. This red curve, which is f of x, and then this green curve, which is g of x. And let's assume that the start of these two curves is a and the end of these two curves is b. Now let's say you are asked to compute the area between these two curves, that is this area. All right, so how do you compute that area? You could use Riemann sum, because you learned Riemann sum early, so you can use Riemann sum. If I just refresh your mind, Riemann sum works like this. You take a stripe in this region. Let's say the region is A, and then you make a stripe on that. So this is that stripe. Let's say that stripe is AI. All right, now what to do? We can say this A equals. Now, first of all, let's say this A can be approximated by sigma AIs. Okay, this A can be approximated by sigma AIs. Let's say you have n such AIs, n such stripes. This is very simple. Let's say you are given this piece of paper. So what you do, you take a scissor and then you make stripes like this. All right. Those stripes can be added together. That addition is given right here. AIs. You just add AI. Sigma means adding. Okay, that will give you an approximation for A. That is the total area. If you want to get the exact value, that means if you need something like A equals, okay, in this case it's A equals, not A approximated. If you have A equals, then you write that to be limit n goes to infinity sigma AIs. I goes from 1 to n. All right, that means you sum them up, sum AIs, and then you make sure n goes to infinity. That means n goes to infinity means you are making infinitely many such stripes. Okay, that's a lot. You are making infinitely many. Why you make infinitely many stripes? Because when the width is high, let me zoom this. Let me zoom this stripe. If you zoom that stripe, this stripe will look like this. Okay, so top and bottom are not flat. Since they are not flat, you make an error. All right. So this AI is kind of, you just consider that's a rectangle. Whenever you want to compute the area of this, you consider that as a rectangle. Okay, that approximation neglects that small piece and this small piece. So it contributes to error. That's why I'm saying you should have very narrow width. If the width is narrow, if this width is very narrow, very narrow, then you can just approximate the top and bottom are flat. For that you have to make infinitely many slices. Okay, so for that you have to make infinitely many slices. That is how do you represent infinitely many slices in mathematically. That means you just say n goes to infinity. This n is number of slices. Okay, let me write this n is number of total slices, where n equals number of total stripes. Stripes and slices are both same. Alright, that's your n. So you make n goes to infinity. That means you technically what you are doing here is you are just making infinitely many slices. Actually, this quantity can be given by definite integration from a to b f of x minus g of x dx. All right, so this sum with the limit can be given by that. All right, so you learn this one in the early section. So that is the area. That's the area what we need. Okay, so this is the motivation. The good thing here is you are using a known kind of known formula which is taken which is computed by using a Riemann sum approximation. Okay, so this is called Riemann sum. Riemann sum. All right, that's the motivation. Then we go to a theorem. This section has two theorems. This is the first theorem. First of all, I write the theorem. Let f of x and g of x are two continuous functions. Are two continuous functions. The area A bounded by the curves y equals f of x y equals g of x, comma, and the lines x equals a, comma, x equals b is. So now I'm going to write down the area. First case, I would say A, part A. This area is let me write A equals, if the area is A equals integration from A to B, f of x minus g of x dx, if f of x greater than or equals g of x. Then b, I'm sorry, it is the same a. Part b says a equals integration from a to b f of x minus g of x dx if gx greater than or equals f of x. Okay, so this is the theorem. Let me explain this little bit. The first case is actually, let me explain first case. In first case, you have f of x greater than or equals g of x. That means the case is like this. Your f of x is which is greater and g of x is like that. So that is the area you are interested about. Alright, so this is A, that is B. This is f of x, that is g of x. Part B, you have the graph G above graph F. Part B is like this. You have A here and you have B here. I'm sorry, you have above graph is gx and the below graph is f of x. This is A, this is B. This is the area A in this case. Alright, so these are the two cases. Always you have to I made a small mistake here actually. I'm sorry, I made a small typo. So this will be gx and that will be f of x. You always have to subtract the below function from the above function. Okay, so in this case, this is the below function, which is gx, below function. Gx is below function. And you are subtracting the below function from the above function. In the next case, f of x is the below function. Okay, and above function is g of x. So you just subtract f of x from g of x. Keep that in mind. Well, now we go to examples. Let's discuss the first example. In example number 1, compute the area bounded by y equals e to the power x, y equals x, x equals 0, and x equals 1. Alright, so let me draw this. Now you have two curves and two lines. These are the curves. That is a curve. This is a curve. Actually, this is a line, of course. This is a curve. You can consider line as a curve too. So let's draw that and that. Y equals x is actually a graph that passes at the middle of the first quadrant. So this is the first quadrant. So this entire thing is the first quadrant. That graph passes at the center of the first quadrant. So this is y equals x. And in the next case, y equals e to the power x. Okay, this is the exponential function. If x equals 0, what happened to this curve? If x equals 0, y equals e to the power 0, which is 1. When x equals 0, this is x, that is y, the function value is 1. Okay, it starts from here. Right? If x equals 1, y is e to the power 1, which is e. Okay, actually e is, if you can remember, which is 2.718. Alright, so that is the value of e. That it should be, let me just get this little bit down. This is 1, you could say this 1, this is 2, and 2.7 is somewhere here. I'm just plotting that curve. I just found 2 points. The first point is 0, 1. The next point is 1, 2.7. I found 2 points. 0, 1 point is already done. Then the next point is 1, 2.7. That is right here. Alright, so this curve goes like that. Alright, we have drawn those two curves, and then you have to plot, mark that one, x equals 0, which is this line, x equals 0, and then x equals 1, which is that line. Alright, so now the area should be like this. This is the area that you have to compute. That's the area you should compute, which is A. Alright, now go forward. This is y equals e to the power x. Above function is e to the power x. This should be above function minus the below function. Alright. So you write a to b. Above function, which is ex, minus the below function, which is x. Let me include another term because it is clear if I include another term. What I want to say here is the above function, you could say this as f of x, this as g of x. Alright, this is f of x minus g of x. And you have to differentiate that. Limits. Now you have to find the limits. The lower limit is 0, upper limit is 1. That's how x varies. X varies from 0 to 1. So 0 to 1. Alright, now you have to put f of x, which is e to the power x, and then this gx is x. So you have to integrate this thing, this part. All right. Now you can use the rules of integration. There are two functions. The first function is here. The second function is there. Now what do? You use a rule given in one of previous section that says integrate each function separately. So I'm going to integrate e to the power x, and then I'm going to integrate x separately. Okay, integration of e to the power x is just e to the power x, and then you have to put the limits from 0 to 1. Integration of x is actually x square over 2. If you want me to put how it comes, it is like 1 plus 1 over 1 plus 1. Limits are from 0 to 1. Now here you substitute the upper limit, e to the power 1 minus e to the power 0. And then this is minus half x to the power 2. That means 1 to the power 2 minus 0. All right. If you can't remember the integration formula, I'm going to write those formula here. Integration of e to the power x is just e to the power x. Integration of x to the power n is x n plus 1 over n plus 1. All right. So now simplify. E to the power 1 is just e to the power 0 is 1, and here it is minus half. Now you simplify this, what you get here is e minus 1.5. Alright, so that is the solution for example number 1. Now we move to example number 2, which is harder than example number 1. Example number 1 says find the area enclosed by the parabolas y equals x square and y equals 2x minus x square. There are two parabolas. Now you have to find the area enclosed by those two parabolas. First thing is to plot them. All right. First thing is plotting. That's easy because you have learned how to plot functions in Calc 1. So you need Calc 1 knowledge here. Let's say this is y, that is x. First, let me draw y equals x square. All right. You know the shape of that. This easy function. It goes through the origin, and it is concave up. It is concave up. Let's say it goes like this. Give me a second. All right, this is y equals x square. The next function is y equals 2x minus x square. Now you have to draw that. For that, I will recommend you to compute some points on the parabola and then just think about the shape. Okay, first I will try what happens if x equals 0. If x equals 0, your y is 0. Alright, that gives you 0.00. Alright, and then if now it goes through 0, 0, then what I'm going to do is what happen if y is 0. First I found the case where x equals 0. Now what happen if y is 0? If y equals 0, you have 0 equals to x minus x squared. Alright, now you have to solve this. This is an equation. It's a quadratic equation, so you have to solve that. 0 here, then you can just factor x. I factored x. If you factored x from here, you will get 2, and if you get 1x out, then you will have x here. Alright, this says x times 2 minus x equals 0. So you can write at this point either x equals 0 or 2 minus x equals 0. That means solutions are x equals 0 or x equals 2. Alright, we already found this point x equals 0 point because we already found 0, 0, and the new point we found here is 2, 0. That is, points are 0, 0, x is 0, y is 0, here x is 0, 2, 0. Now we found another point. So let me draw those 2 points. The first point you found is right here, 0, 0. Another one is 2, 0. Let's say this is 2. 2, 0 is right here. Alright. Now you found 2 points. Alright. You need 3 points to plot this. This is, let's say this is 0, 1, 2. Alright. Now just find the point at 1. What happens if x equals 1? If x equals 1, because I know this is 1, so I'm going to find corresponding y at x equals 1. If x equals 1, you have y equals 2 times 1 minus 1 square. So this is actually 1. So the corresponding point here is 1, 1. When x equals 1, y should also be 1. So it should go through that point. Okay, so you found 3 points. Now you know the shape. Since it's a parabola, so shape should look like this. That curve is y equals 2x minus x square. Alright, the area enclosed, but it says area enclosed. What's the area enclosed? That is this area. Alright, that is the area enclosed. Since you know the area enclosed, now finding the area is really easy. Now you have already drawn the area, so computing that amount is easy now. Okay, so you write A. Let's say this is A. A equals integration. Here x is 0, here x is 1, 0 to 1. What's the above function? This is the above function, red. Above function should be 2x minus x square the below function should be that, which is x squared. Okay, so you have to compute that. Alright, so you got the formula. Now it is just simple integration. Let me simplify this further. It is integration from 0 to 1. I write 2x, here minus x, here minus x, then it is 2x square. Okay. Now what do? I just use the rules of integration. I have two functions. I integrate each function separately. Alright, here you can take 2 out, it's a constant, and integrate x 0 to 1. Here 2 is a constant, you can take 2 out and integrate x square. So this is here you are using the power rule. I have already written the power rule somewhere here. This is the power rule of integration. You could use that rule. Here the power is just 1, x to the power 1. So you write x to the power 1 plus 1 over 1 plus 1. And then you put the limit 0 to 1. And 2 times again, this is the power rule. The power here is 2. So you write x 2 plus 1 over 2 plus 1. Then integration from 0 to 1. Alright, then you write 2 over 2 x to the power 2 from 0 to 1. Here 2 over 3 x to the power 3, 0 to 1. 2 over 2 is just 1. You can cancel this 2 with that 2, and then you substitute the upper limit, which is right here, and then substitute the lower limit. So upper limit is 1. You put 1 square minus 0 square. And then here you write minus 2 over 3, 1 to the power 3 minus 0 to the power 3. Right, this is actually 1 minus 2 over 3. Alright, that is, you can just simplify this by using your knowledge of fractions. You write this to be 3. The denominator is 3, the common denominator. The numerator is 3 minus 2, which is 1/3. Alright, so that is the solution for that. Example number 2 is not hard, which is an easy problem. The integration part is easy. This is the integration part, which is easy, but the getting this formula is little hard. For that you have to draw this curve, these two curves. You have to draw these two curves in order to get that. Alright, so you have to make sure that you could draw them. Alright, let's move to the next part. Now I have to bring your attention into something. That's what I'm going to write here. I put an asterisk. Some regions are best treated by regarding x as a function of y. All right. So far we considered y as a function of x. See, this is what you see here is f of x. That means y, this y as a function of x. Okay, this y equals f of x, this y equals f of x, y as a function of x. And then this gx is actually y equals g of x. That means y as a function of g of x. All right, so let me make that modification here. This is actually y equals, this is y equals g of x. This is y, that is y. Right. In the next case, what we do is we just consider x as a function of y. That is simply we just rotate the region, kind of rotating the region. Okay, first of all, I will give you a theorem, and then I will explain this little bit. All right, let's write down the second theorem, second and last theorem of this section. Let f of y and g of y are two continuous functions. Two continuous the area A bounded by the curve y equals f of x equals f of y, x equals g of y, and the lines y equals c, comma y equals d is part A equals integration from c to d f of y minus g of y dy if f of y is greater than or equals g of y, and b, part B, a equals integration from c to d g of y minus f of y dy if gy is greater than or equals to f of y. All right, so this is the formulation. Okay, now go back here, go back to this point. This says some regions are best treated by regarding x as a function of y. So that's the point you have to get. Okay, when I draw these two cases, you can understand. Part A, this is your y, that is your x. Now you have to draw x equals f of y. Now x is a function of y. Okay, now x is a function of y. Or the shape is little different now. Shape is little different. The shape is like this now. X is a function of y. And also the next curve is like that. These are the two curves. Okay, so this is actually the first curve is g of y, and that is f of y. you see f of y is greater. F of y, so that means if you just consider this as the direction, the positive direction you want, and this as the axis that you consider, f of y is greater than g of y, right? F of y is greater than g of y. Here you are considering this as the axis for the comparison. Now this is true. F of y is greater than g of y. Right. Now you have to check everything reverse, not in the proper order. You might not be familiar with this, but just think about it. All right. Now that's how it works. It says y equals c, y equals d. That means this is c and that is d. So this is the region of interest. Okay, that's the region of interest. All right, that's part A. In part B, you have the same scenario, but f of y and g of y are reversed. That means they are switched. This is part B. Here you have your x, here you have y. Now you have this curve like that. Let's say that curve like this. This is C, this is D. This curve is actually, it says g of y is greater than equal to f of y. Now you are considering this as the axis of comparison. Okay, that's the axis of comparison. Now f of y is smaller, so this is f of y. That is g of y. All right. So now these are the two cases that we interested of. All right. Now let's move to an example. This is also same as the previous theorem, but only thing is everything is just switch. Just switch to x-axis. Previously everything was defined on x-axis. Now everything is defined on y-axis. See, everything is defined in terms of y. Let's move to the first example. Actually, this is third example of the section. Find the area enclosed by y equals x minus 1 and y square equals 2x plus 6. Alright, so this is the given problem. First draw it. The first step is to draw what is given here. Here this is your y and let's say this is your x. First draw this line. It says y equals x minus 1. In order to draw a line you need 2 points. Alright, so, if x equals 0, you have y equals minus 1. That will give you the point 0 minus 1. If y equals 0, you have x equals 1. So that will give you the point 1 comma 0. Okay. First point is 1 comma 0. Let's say this is 1 1 comma 0, that's this point, and the other point is 0 comma minus 1, that is this point. That line passes through these 2 points. Alright, so this is the line y equals x minus 1. Alright, now let's draw this part, the curve. Now it is y square equals 2x plus 6. As before, you have to plug some points. What happens if x equals 0? If x equals 0, you have y square equals 6. That means give me a second. That gives you y equals plus or minus the square root of 3. Right, so this will give you 2 points. The first point is 0 comma square root of 3. The other point is 0 comma square root of minus 3. Alright, so that graph crosses 0 comma square root of 3. This is, and you know, this is minus 1, that's 1. Square root of 3 is between 1 and 2. So this crosses somewhere here. Let's say this is minus the square root of 3, and that is minus the square root of 3 plus the square root of 3. Okay, that parabola should cross those 2 points. Okay, then we plug y equals 0. What happens if y equals 0? If y equals 0, you have 2x plus 6 equals 0, then x equals minus 3. Okay, the next point is minus 3 comma 0. X is minus 3, minus 1, minus 2, minus 3, and y should be 0. So it should pass us through that point. Okay, in this case the parabola should look like this. It should pass through that point and this point. And again this point and that point. Okay, so this is the parabola you have. Let me draw it again. So it's a parabola. It should look like a parabola. And they should look like this. Alright, so this is the corresponding area. Alright, so that's the area. Now you can see that let me show why we need this theorem, the second theorem. This is the second theorem. I explain why we need the second theorem. Let's say we don't have the second theorem. Alright, let's say we don't have the second theorem, then you have to use the first theorem. Okay, if you were using first theorem, this is the way you have to make slices. Okay, if you're using the first theorem, this is the way you are making slices. Okay, for these slices, those slices are parallel to y. If you make slices parallel to y, you can see that the top function is that function is that one, y square equals 2x plus 6, that's the top function. How about the below function? Below function varies, right? For this stripe, for this stripe, the below function is this curve, this parabola. If you take a stripe right here, the below function is this straight line. Now see, the below function varies, so it is hard to use theorem 1. It is hard to use theorem 1. In order to use theorem 1, you should have above function and below functions. You should have one above function and one below function. Okay, these functions should not change. Go back and see here. Above function is one function here. The below function is that. In this case, the below function varies. The above function keeps same. It doesn't vary, but the below function varies, right? So then theorem 1 can be used here. Okay, so now go to theorem 2. Or I can't delete anymore. Let me use the eraser. Alright, let me draw them again. Now we make stripes like this. That is theorem 2. Theorem 2 says make stripes like that. Okay, so this is the corresponding stripe. For that stripe, you can see always the above function is this straight line, the below function is that parabola. So the theorem 2 works well in this case. That's why we need theorem 2 here. Alright, let me mark this curve is y equals 2x plus 6. Alright, now I'm going to use the explanation. The area A, let's say this area is A, that area equals integration above function. Okay, above function, it should be, let's say, f of y minus g of y. Okay, this, let's say this function is f of y. I'm sorry, let's say that this function is f of y, the above function, and that is g of y. That's the below function, g of y. Alright, and then you have to find from where to where, the lower limit and upper limit. For that, you have to just find that intersection point and this intersection point. Those are the places, those are the boundaries of the y-axis. Alright, the y-axis start at here. For this region, y-axis start here. For that region, y-axis stops over there. Alright, for that you have to solve. Okay, solve these two curves. Let me take some space here. I'm going to push this little down. To find intersection points, I write to find the intersection points in solve two x plus 6 equals x minus 1. That means I'm sorry, I made a small mistake here. The mistake that I made here is this is y square. Okay? Then if it is y square, then this should be square root of that. You have to solve that. This will give you this will give you y equals 2x plus 6 square root. And then you have to equate that to this. Alright, now take this even down. Now you're gonna solve this for x. For that, first I square the both sides. Then I'll get 2x plus 6 equals x minus 1 square. So that is x square minus 2x plus 1. This is 2x plus 6. And then I just bring all the terms in right hand side. So I have x square minus 2x plus 1 minus 2x plus 6 equals 0. Alright, then you write this to be x square. This is minus 2x is minus 4x minus 5 equals 0. And then you have to factor that out, which is calc 1. You learn how to factor this. For that, I just consider x here. Okay, so give me a second. What I do here is first of all, I find factors of 5. Factors of minus 5, which is minus 1 times minus 5 times plus 1. Those are the factors of minus 5 times minus plus 1. Then what I would do, I just add minus 5 to 1. If I add minus 5 to 1, I will make minus 4, which is this coefficient, right? That is that. So that means these factors will work. That's a shortcut method. That's what I teach in my Calc 1 class. How do you find factors of this? First find factors of minus 5, then you will get minus 5 and 1, and then add those two factors and check whether you can make this coefficient. So you can make that coefficient. So these two factors are good. Alright, then what you do, you just use those factors minus 5 and plus 1. So you write this as x square, then here you write minus 5x plus x minus 5 equals 0. Now you split the middle term into two terms. This was the middle term. You split that into two terms, which is okay because minus 4x is minus 5x plus x. Alright, then you just consider the first two terms and then find common factors. X is common, then you write x minus 5, and then next two factors, find what is common. What is common is just 1. So you write x minus 5. And then you consider these two factors, these two big factors, and then find what is common. X minus 5 is common. If you take x minus 5 out, x will remain from here and plus 1 remain from here. Then it equals 0. This is a shortcut method that I teach in my Calc 1 class. Alright, so these are the factors. Then this means either x minus 5 equals 0 or x plus 1 equals 0. That means x equals 5 or x equals minus 1. Okay, here x equals, that means those are the two values, x equals minus 1 and x equals x equals 5. This is the case where x equals 5, that 5 is here. This is give me a second. I have to do a small modification here. According to this finding, here it says x equals minus 1. At x equals minus 1, these graphs should cross each other. This is x equals minus 1. That means this, let me do that modification. What I want to do here is just, I have to get this point and this point at the same place. They should overlap. That means this is the intersection that should go through minus 1. Alright. That's what I'm gonna change here. Alright. So for that, let me delete this line and then redraw the line. Give me a second. No, I think that's correct. It's my confusion. This says x equals minus 1, not y equals minus. X equals minus 1 means this place actually. This is minus 1. X equals minus 1 and then x equals 5. X equals 5 means this is 5. I also confused because this plot is rotated. That's not 5. Okay, this is 5. And then you have to find out corresponding y values. Okay, when x equals 5, what is y value, and when x equals minus 1, what is y? When x equals 5, y equals, you can use one of these lines. I can use this line to compute that. That means when x equals 5, y equals x minus 1. That means 5 minus 1, 4. When x equals minus 1, that is minus 1 minus 1, which is minus 2. Okay, this is minus 2. Everything is compact, so let me Let me mark an arrow. This is -2 and that is 4. See, 4 and -2. So those are the places where this y varies. Y ranges from -2 to 4. Alright, let's go forward. And these are actually from -2 to 4. That's how y varies. And then you put dy here. And then integration -2 to 4. And then you have to find f of y. Okay, that is the above function. Above function is this is straight line. This is f of y. This is the above function, f of y. That is, you have f of y, you have this function to be y equals x minus 1, f of y related to y equals x minus 1. And then you have to solve this for x. You have to solve this for x. So that will give you f of y. Right? Let's solve this for x. How do you solve this for x? You just push -1 to the other side. You can write this as x equals y plus 1. What you have done is you just bring this -1 to the other side. So this is actually the format of f of y. That means function of y. Okay, y plus 1. Actually, the original format is a function of x. So this format is actually function of, let me mark it. Let me get this out. This is the format of f equal function of x. That's the function of x format. Now I have function of y. All right. That means this should be y minus 1. Now work. This is the work for that. And then I'm gonna work on this. I need g of y, but whatever given here is not g of y. Okay, whatever given here is y square equals 2x plus 6. 2x plus 6. All right. If you get the square root of both sides, this is y equals 2x plus 6 square root sine. This is actually f of x. What I need is, I'm sorry, not f. Let me put g. That's the second function. What I need is g of y. What I need is g of y. You see that? G of y. So you have to just solve that for x. Okay, you have to solve this for x. Let me take this little down. And then let me take this little down. And then let me write a little bit here. To find f as a function function of y, just solve that for x. I wish that information is helpful for you. get this closer. And then what I would do, I just take this closer to, alright. Now this I decided to write extra here because it might helpful for you to understand. To find g as a function of g as a function of y, just solve y equals 2x plus c 4x. I'm going to solve that for x. That is, I have y equals 2x plus 6 square root, and then I'm going to solve that for x. That is, I just square the both sides. Then I have y square equals 2x plus 6, and then I bring 6 to the other side, and then I divide both sides by 2. Okay, then I have x equals y square minus 6 over 2. This is a function of y. That means g of y equals y square minus 6 over 2. Okay, that part is right here. So I'm going to bring this into that. So you write it to be minus g of y, which is y square minus 6 over 2, and do dy. Alright, now simplify a little further. So you write this to be integration from minus 2 to 4. Here this should be y plus 1. Okay, then this is y plus 1, and then this should be minus y square over 2 plus 6 over 2 is 3 dy. Again simplify, integration from 2 to 4, y minus y to the power 2 over 2, and then this should be plus 4 dy. Alright, now I'm going to integrate this. First integrate y with respect to dy. That is integration from minus 2 to 4 y dy, and then minus half is a constant. You can take that out. You write y square dy from minus 2 to 4, and then this 4 is a constant. You can take that out. Then 1, you have to integrate that one from minus 1 2 to 4. Alright, then there are 3 integrals. You can integrate each separately. Then here you are using the power rule. So it is y square over 2 from minus 2 to 4. Here minus half. Here 2 plus 1. 2 plus 1, again power rule. And let me directly put 3 because you know how it comes. 3 over 3. Here y to the power of 2, that you just plug the upper limit, which is 4 square minus 2 square and minus 1 over 6, 4 to the power 3 minus 2 to the power 3, and here plus 4 times 4 minus 2. Alright, you have to simplify each. Once you see, this is simple simplification. You can use any electronic device if you need. If you simplify this, you will get 24. Okay, so that's the final answer. We discuss 3 problems in this section. This is a very easy section. The section is followed or supported by 2 theorems. So this is the first theorem. This theorem helps you to integrate with respect to x, integration with respect to x, and then you have the next theorem which helps you to integrate with respect to y. Okay, it helps you to integrate with respect to y. We discussed 3 problems. I assign you some problems in your homework, so you please do them, so you'll be fine. Okay, thank you very much.